As I was preparing to do the examples in today's lesson, 6.4 notes, rational exponents, I was just kind of thinking through some things and thinking, well, maybe I could walk you through a few little details about exponents. And we already know things like this. We already know that 2 to the 4th power is 16. 2 to the 3rd power is 8. 2 squared is 4. 2 to the 1st is 2. And 2 to the 0, maybe we didn't know this, but we should know this. Every time you take any real number to the 0 power, you're going to get 1. So if you take a look at how we got from one number to the next, each exponent is reduced by 1. So if each exponent is reduced by 1, then what happens to each of the numbers? You might notice the pattern here that when the exponent is reduced by 1, you have 1 less 2 as a factor, so you're going to divide each of these numbers by 2. So when you go from 2 to the 4th to 2 to the 3rd, you go from 16 to 8, which means to get from 16 to 8, you either subtract 8 or you divide by 2. But the pattern has to work for all these numbers, and we can see that every time you go reduce the exponent by 1, you are dividing the number by 2. So 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1, and 1 divided by 2, so we're reducing the exponent by 1. 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. Then we have 1/8, and then we have 1/16. That's not necessarily something that you have to remember, but it does help you see perhaps the pattern. Why would 2 to the negative 1 power be 1/2? Well, I'm going to talk about that. If you look at any number, let's say we take the number 5 or the number 3 to the 2nd power, or maybe we take this 2 to the negative 3 power. No matter what number you select, no matter what number you're looking at, any real number, it can always be written over 1. So 5 can be written as 5 over 1. 3 squared can be written as 3 squared over 1. And 2 to the negative 3 can also be written as 2 to the negative 3 over 1. So what I want you to think about is that you've got two numbers. You've got a numerator and you've got a denominator. So numerator, and we have the denominator. Now I know you already know this. I get that. But when you look at the numerator, I want you to think of the numerator as upstairs. And I want you to think of the denominator as downstairs. In fact, numerator has a U in it, and U is what upstairs starts with, and the denominator has a D in it. In fact, it's the first letter of the word downstairs. So you've got upstairs and downstairs, and then you've got that line in between the numerator and the denominator. And I guess you could think of that line right there either as the floor for the upstairs or the ceiling for the downstairs. So when you look at a fraction, I want you to be thinking about that fraction in terms of upstairs and downstairs. So why are we talking about upstairs and downstairs? Well, you'll see that in the next couple videos. But when you have an exponent in the upstairs, so 3 is being raised to the 2nd power, and we know that the power of 2 is a positive number. So when the power of 2 is a positive number, you leave it alone. If you have a positive exponent upstairs, you leave it upstairs. But then, so anyway, 3 squared over 1 is just 9 over 1, or just 9. So that expression has a value of 9. So here's the deal. Here you have a negative exponent. You've got an exponent that is negative, and it's upstairs. So what you do is, when you have a negative exponent upstairs, you need to change it to a positive exponent, but you have to put it downstairs. So 2 to the negative 3 becomes 1 over 2 to the positive 3. So in other words, if an exponent is negative and it's upstairs, you move the exponent downstairs and make it positive. Likewise, if you have a Let's say you have say 1 over 4 to the negative 2. Let's say you have a negative exponent, and that happens to be downstairs. Well, it works the same way. If you have a negative exponent downstairs, you move that exponent, you move the whole term, 4 to the negative 2, and you move it upstairs, and you make the exponent positive. You can leave it as 4 to the second over 1, or you can make it just 4 to the second. Well, we know 4 squared is 16. So 1 over 4 to the negative 2 happens to be 4 squared over 1, which is 16. And I forgot to finish this one up. 2 to the negative 3 over 1 is the same as 1 over 2 to the third, which is 1 over 8, which is what we saw over here anyway.